Hi, I'm going to show OllyDbg and I show some codes over there. This is the while I'm opening. If you download OllyDbg, it's gonna be a zip file. I open it and go to execute it. Okay. If you open, you're gonna see that there are some windows already open. It shows registers. You have assembly, memory, and a stack. Here are some of the windows you can open, like threads and so on. There are the list of the windows you can open. Here is the part you can debug it, step into, step over, run till breakpoint, and so on. If you go to debug, you can see here the same menu, the buttons you have there, the same options. Let me open a file. I'm gonna open exe file which is related to hello. Let me see here. Um, Sorry. Um, the hello file that I'm going to is just includes, or let's say import studio.h, and is for printing hello world, and after that it's return. I'm gonna open it with OllyDbg. Is hello one.exe. If you open it, since the last time I opened it and put a breakpoint, it's whenever you close the debugger or close the file, it's gonna keep the previous breakpoint you have on that file. So remember this, that it's if you don't need them, you have to click it and toggle it. What breakpoint? Say breakpoint toggle. It's gonna go away. But what I showed you, whenever you need to any places you need to have a breakpoint, you can click on the instruction, right click and breakpoint. You have toggle for software breakpoint, conditional to have a conditional breakpoint. You can also have a memory hardware breakpoint. The hardware breakpoint is using the register. It doesn't change any on stack, doesn't push any change in the memory or in the code. It's managing by the register. So but you have limitation on the number of the breakpoints you can have in the files. I think it's 4 times. You can have only 4 simultaneously breakpoint. The other one is, you see memory on access and memory write. It's not for the part you are having the instruction. If you want to have a breakpoint for the memory, right click on the memory and put the breakpoint for memory on access or write. You can have, even for the memory, you can have hardware access, hardware breakpoint as well. So it's for every breakpoint can be software or hardware breakpoint, and for the memory you can have memory breakpoint, and for the instruction you can put toggle for having software breakpoint or hardware breakpoint. You can put a hardware breakpoint like this. What is do the hello world. Before I go putting any breakpoint to jump on that one, we know that it's just having a writing hello world. What I'm gonna do, I'm gonna debug it, start running from the first command it has. If you go there, you can see that it has some uh, it doesn't have only the user code. It has some pushing and popping, pushing some stuff in the stack, saving some stuff. These are the related for the, we say this is the compiler stuff is related for that one. and based on the debugger you are using, it's may be changed. So we don't need to take care of them. Just know that there are some others that are added. If I go if I put a step into, it's gonna go to the, if there is a DLL or system API, it's gonna go into that code, or if there is a function, it's gonna go to into that method function. But if I put a step over, it's gonna just run it and go to the next instruction. If I'm going to, you see that as soon as I open the command, also is trying to write hello world. I go to, if I while I am going step by step, it said that it's moved to this memory AH. Let's see the register AH here. EAX, it has, you know, the extended AH. The part at the bottom right left is the AL and AH. It said that write the AH to EBP, the memory which is related to EBP -248. It's gonna write it in this memory. You can see the memory over here, and what we have here is the stack. I'm gonna go step by step over these till reaching the writing the memory, writing hello world. If we go so far, is related to compiler sub. I can see the print, and you see some of these comparisons, all these things. Okay. You see the part they are changing when it's right to the registers or writing there, and instruction pointers. You see that instruction pointer register shows where in the debugging we are. You see that it's changing. Here is showing the address I have here for the instruction. As I go over that, it's gonna change to the next one. You see. And going over this, let me see if we reach the part related to, not yet. The other things you can see that here, when the instruction executed, it shows some information what's happening. For example, here for moving, let's go over it. It shows that here it said that what would be the stack address, what would be changed to ECX will be changed to what it would be load to ECX, and every time when you see for the push, it said that ECX, what's the value of ECX, and instead pushing to ECX, what will be the result of this instruction. It shows the information like this. We haven't reached that part still. I think I should be better to have a breakpoint. Continue read. Let me find where the code is, and I'm gonna run till that breakpoint. Let's see the command I have here. I'm gonna pause to find the Okay, I'm gonna put breakpoint here, breakpoint toggle, and debug, and run it till it reach this place. And what I'm gonna see, we don't see the step over. We're gonna see that the ASCII is here, push EAX. If I push EAX, the CEAX is this one, is showing the ASCII character. It's gonna push this register to the stack. Let's see that. In the stack, the value of the ESX is in the stack, and it's called for the printf. I don't step into to go to the API's code. I'm just step over it, and it's gonna print the hello world for me in the screen and go step by step over these the rest of the code to leave and return. But as I told you, there are some other codes that are related to the compiler, so we have to know after working wise you can know that which part you have to move. Or the other thing is that when you are debugging, you can say that execute till return or execute till user code. If in case you stuck in the DLS code or APIs code, you can get run over that one to go over this, or you can find a place you want to debug and put a breakpoint. I'm going to show you some tricks that we can use for debugging. After while working, we get used to that one. And remember, these are the menus we have. The other one, we can see list of the threads here, this of the breakpoint. If you don't remember where you put the breakpoint, if the code is, you can put the click on the breakpoint and you see where you have the breakpoint, and you can disable it, edit conditions, and so on, or even remove it. What else? Let's go to another example. The other thing is I want to show you is the function epilogue and prologue. Is saying that whenever it wants to go into the functions, it push the stack pointer and move the top of the stack to the instruction pointer to the method is calling, and also it's put a space in the stack for the local variables on the, based on the local variables on the method. So based on the size of the local variables, it subtract the stack, because we know that the stack has the lowest part has the bigger memory, and it's while it's growing, the memory is decreased. The location of the memory is decreased, so the stacks are counting down. So it's gonna stop the stack with the size of the variable. Let me show you here. When it wants to return, is do vice versa, is put the stack pointer to the place that is already was, and it pop the base pointer. Let's see here in the, for example here, let me show you in the sample that we have for the variables, for the let's say for the method. The sample I opened is sample 16-3. The first part you see is pushing the EBP, move, EBP, ESP, and sub ESP with 8, because it has it's the size of the variables. And after that, you see that is it put EAX1, and it put in this address EBP -4 the EAX, and it seems that is when it puts the variables, the value in the stacks, they are local variables. It puts 1, and after that it puts 2 in the stack. And even is a stack segment, it shows that this segment stack frame related to this method. And I forgot to show you that here, when you see something, the line like this, each of these lines related to the stack frame, which is related for every method. If it goes to the new method, it's gonna create another frame for that one, and after calling that, you see these lines will be showed up, and you can see that these are related. These are the local variables related to one method. That's what you can see when it start a method. And there must be somewhere when it wants to leave and return, it's gonna be some pop, push the data, move the value, call, add, move ES6, leave. This one doesn't here. Anyway, you can find if there is something related to the new method, but what I have here is just one method related to main. That's the reason I can't see the other methods. If there is a method but through that, like what I have in the PowerPoints, I then wrote it, and we don't have an example, but you can have it all yourself. What will happen if we have two methods, and in one of them the other one's calls, you can what will happen is gonna push these variables to the stack, and after that going to call this one. First one is gonna put the arguments, the values that we have for variable for this function b, or a and p, which is year 3 and 4, and that after that is gonna create the return, create a local space for local variables. But you see that stack, it push the address of the function a. It means it's gonna return this place. The reason is that after returning from this method, it has to return back to the place that it started and ignore the frame that is related to function b. It has variables a, and you see that we have two variables, so it puts 2 byte for variables. Since it's init is integer, so it's gonna be word, 2 words for variable a and variable f. The other things, let's go. I have the explanation here, you can go through that. Let me show the other one. This is the local variables. I already have it here for you. Let's show you. These are the local variables I showed you. What will happen if it wants to write in the stack, it put it in the register, and then moving from the register to the a stack, and again the other number is put it over there, and when it's the local variables, we save it in the stack. Let's go to the next part. Let me open the global variables. When in all the in sample 16-6 we have the global, I have a global variables in it a equal to 0. What will happen is gonna move the value for a to ESX, and for it wants to put this value in b. B is the local variables. For local variables, we know that it's in in a stack for and the name of our local variables start with local dot 1, and for EAX it first put the value that we have for local variable in EAX and put it in the data we have for the in the stack, which is B local variables. Let me show you in VMware. Here I opened sample 16-6. It's shown here that it has a global variable a assigned the value is 0, and it put the local variable b a into the local variable b. To identify global variable, you see here that it said that move EAX the memory for 02000. The memory for 02000 is 0. This value is 0. What happens when it's write DS? It means that it's in the memory, it's not in the stack. And what will happen is put EAX in the stack EBP-4, which is the related to B variable B. There is one way I think we can analyze the code. Let's see if it show me. It's supposed to show them with the variables name. The variables name can be local something. If remove analysis, it's gonna change to the some memory names or the stacks with like this. But let me see if I can configure that to show you the variables with the name of the variable, something like local dot name. I try to hit debugging. After putting the run, I was able to right click and analyze code works. But the thing is, it doesn't even change the variables name, local variables name. Still, for me, there might be something with the configuration. Anyway, what you need to know is when it start with DS, it means that it's in the memory, not in, and the only local variables are saved in the stack, not the global one. So when it's in the memory, everybody can have access to that one. Let's go to the next part. Is we checked it. Let's go to show. Let me show you the pointers. When you have a pointer, it's like this. Pointers in fact is creating a variable of type memory. Is when you say that pointer PTR, it means that we have a variable's names PTR, but it's referred to point to a memory. And a is equal to 1. When it said reference a, it means the address of a put in the pointer. And what we see here is said that it moves value 1 to EAX and put EAX in the local variable. SS means it's in the pointer, it's in the stack, and it's a local variable. And where put value 1 to a. The reference of the a, which is the address of the a, you see that it said that when it's in the bracket, it's the address of local variable. Put it into EAX and put the EAX into the stack, where in local 2, which is the local variable is pointer, but it's from the type address. It said that in the stack, in this address, put the value we have for local the address of the local variable. So what we are saving in the stack is in fact the address of local variable a, is local variable a. Let me open it in the debugger. Okay, I opened sample 16-5. If I let me put a breakpoint here, breakpoint toggle, what we see that is gonna put a value 1 to EAX, and then put this EAX in the local variable. and to the stack, in the stack, and it's gonna load this value to here into the add EAX to the register EAX. Let me see. Let's run step by step. Let's okay. Moving. It seems that it's, I don't know why it goes back to, okay, it moves 1 to EAX, and I'm gonna go, it adds the stack pointer to 4 because it wants to create another local variables to put the address is 4 byte. And what it happened, it puts this address in the EAX, load this address of the EBP minus 14 to the EAX. EAX is here. The first it was value A1, but after that is put the address of the A, it wants to put into the pointer. Address of the A, let's see. It's gonna load it over EAX. Okay, you see that the value of the EAX in the stack, and then it wants to load the local variables address to the EAX to EAX variable to EAX. Let's see. Jump over it. Let's see. Okay. What we have here, EAX019FF5C, 0019FF5C is the address we have for local variable A, and it put it is the address of the A, and it put it into the register EAX. And let's go further. Is have to, what we have here is put it in the EAX. What's the what it's gonna do is gonna put this address to the local variable which is pointer, and it's gonna push this one to the stack. So let's push it to the stack. What will happen? The address of the 5C, the address of the A is pushed to the stack to the where its pointer variable pointer is located. Let's see. Let me put both together. What happened? We had A equal to 1. Doesn't matter what's the value of it. The address of the 1 it was first put it in the register EAX, and after that from EAX it put to the stack, which is where the which is the location for pointer, the local variable pointer. We see that here is the place that refer to pointer. This address is written here. For identifying the arrays, what you the sample we have here is that we have a array of array that has the with name source, the is initialized to 1, 2, 3, and we have another array with the size 3, and it's in a loop. It's moving from one array to another one. I'm going to show you the loops, but here what's happening is that what will happen is gonna move these parts in a memory with the values 1, 2, 3, and it usually what will happen is end it with, and if it was the string in the C node, that is gonna have to end it with 0 to close it in for the APIs that are reading the strings. Here it put the index to 0, and it's a local variable that is gonna push to the stack. And what will happen is gonna compare it with 2, and whatever we have this address of the source is put it to the destination. Is there's a moving that is put whatever is in the source to the destination. These are the coding over that, and for since it's the move, it's jumping to here, and it's do the add the value of the index and do the comparison to compare it to see if it reached the value is equal to 2. If it's greater, then it's gonna jump to the out of the loop. Otherwise, it's gonna continue moving the data and again jump back to where the loop starts. The other example I'm gonna show you is where it's the branching is the if and else, and we know that we have something switch in C that is similar to if and else. When it goes to the machine language, it's gonna be this similar what we have in the if. What is do, it put the value a to 3, and if it's a equal to 3, print a equal to 3, otherwise print a equal to 3. But let's somehow manipulate the code. What I have here is sample 16-10. I already opened it. It's where it said that if after putting compare it with 3, if it's jump not equal to 0 z to this address, let me if I run it, it's gone obviously is equal to 3. Let me show you the code in parallel. Since the value is equal to 3, what you will happen is gonna go to print 3, but what I want to is to print a is not 3. There is a way that we can manipulate the code and change it. Let me find the, let's run it till here. I'm gonna put a breakpoint, toggle and debug run, and compare it with this one. EAX is 3. If I go over it, it's gonna be equal to 0. Jump. What's the we are checking with the carry flag for registers, which is flag registers. Here is number 1, so it's not equal to 0. It's gonna push here to if not 0, it's gonna go to 3 1. Let's see this address to print a equal to 0, jump 0. Let me see if I can change this to assemble jump not 0. Let's say jump 0, assemble. Okay, and if I okay, when it's set field with no operation, it's gonna change it. If there is more bytes left, it's gonna change it to no operations. I'm gonna go assemble. What's happening? So let's see. What will happen is since it's not equal, it's gonna go to a is not 0. It's going to execute this one. Let me see. It's go to print it, call printf, and it said that a is not 3. As you see, what I did, whenever we have based on the based on the condition, it goes through one of two code passes. If we want to debug both of the code passes and we want to see based on the condition what will happen, this is the way we can change the code comparison, because it's based on these registers. It's checking to see if it's zero or not, or we, instead of jump equal or jump not equal to something, what we can do, even what let me see if I can assemble again. We can even write jump jum simply to say that jump to this address, doesn't matter whatever is the condition, we don't care about it, jump to this address because we want to jump to see what's in that code path. This is the one of the approach we're gonna use in malware analysis. The last things I want to show you today is the loops. The loops are similar to the if conditions, but what will happen, here we have I equal to 1. It, since it's not 9, it's adding the I. What will happen is that it put the value local variables to EAX, compare it with the value we have. It can be even not, here is 9, and if there is greater, it's gonna jump to the end of the loop, and otherwise it's continue to do whatever we have in the inside the loop, and after that at the end it's gonna jump to the start, which is going to decreasing I, and going to checking the value of the comparing value of the I with the index we have here, which is 9. If it's for loop, in the for loop it needs to add the value of the variable by 1 or subtract it, and then check it, compare with 9. But based on these, you remember that we have one jump and also comparison.